do one simple thing. Listen carefully to every single word. I guarantee 80 to 90% of this topic will be ready in your mind right now. Physics is actually very easy.
Rules for calculating uncertainties. Here I will discuss 5 rules. Rules for calculating uncertainties. I'll discuss 5 rules here. Number 1, rule for addition and subtraction. Number 2, rule for multiplication and division. First rule, addition and subtraction. Second rule, for multiplication and division. Third rule, for power of a quantity. Third rule, for power of a quantity. Fourth, rule for average of many measurements. And the last and fifth rule for timing experiments. Rule for timing experiments. Let's start from first rule. Rule A, or first rule. Rule for addition and subtraction. I'll start from this example. Once you understand this example, this formula and this rule will be very easy for you. I'm repeating, I'll start from this example. Once you understand this example, this theory, this formula, this rule will become very easy for you. So listen carefully. Here, in last lecture, we measured the length of this marker by using this scale, and the length came out 14.3 centimeter, and the uncertainty was 0.1 centimeter. I'm repeating, in last lecture, we measured the length of this marker by using this scale, and the length was about 14.3 centimeter, 14.3 centimeter with uncertainty 0.1 centimeter. Uncertainty means a little bit more or less from 14.3 centimeter. If anyone didn't understand this point, this is the uncertainty, plus minus 0.1. This is the uncertainty, or this del represents uncertainty. Del means uncertainty. If anyone didn't understand this point, stop video right here. Go back to the previous lecture, watch it first. Otherwise, you won't understand this whole topic. I'm repeating, if you didn't understand this point, stop video right here, go back to the previous lecture. I'll put the link in the description of that lecture. Watch it first. Otherwise, you won't fully understand this topic. So, in that lecture, this del represents uncertainty. This is the uncertainty. Similarly, another length, this 14.3, this 14.3 is the length of this marker. X shows the length of the marker, and del x, this del x shows uncertainty. X is 14.3 and del x is 0.1. Similarly, another length 20.3 is represented here. The value of y is 20.3 and the uncertainty y. The uncertainty is del y is 0.1. In simple, the value of y is 20 and the value of del y is 0.1. The value of x is 14.3 and the value of del x is 0.1. Now subtracting, adding, addition or subtraction. First subtracting. Subtracting x and y. X minus y. X minus y. X minus y means x 14, y 20. X minus y means 14 minus 20. You 14.3 minus 20.3, you will get minus 6. X minus y is equal to minus 6. But uncertainties are not subtracted, they are added, because it's a rule. Rule is uncertainties are added. Keep in mind, remember this. Uncertainty is never subtracted. Even though the quantities or values are subtracted, but the uncertainties are added. Uncertainties never subtracted. Uncertainties are added. Again, uncertainties are added. In multiplication, in division, uncertainties are added. In addition and subtraction, uncertainties are added. Only the difference, percentage uncertainty in multiplication and division. In addition and subtraction, absolute uncertainties. But in both cases, added. Uncertainties never subtracted. Uncertainties, even the values are subtracting, but the uncertainties will be added. So del x means 0.1, del y means 0.1, 0.1 plus 0.1, you will get 0.2, 14.3 minus 20, you will get minus 6. Now, x minus y. X minus y is equal to z. So replace x minus y with z. Del x plus del y. Del x plus del y is equal to del z. Replace with del z. Now, hope you got this. Even quantities are subtracting, but the uncertainties will be added. No formula. Formula says whether quantities you add or subtract quantities, the uncertainties will be added. Formula says even addition or subtraction, the quantities will be the uncertainties will be added. The uncertainties are added. It's a formula and this is a rule. Rule for addition subtraction is absolute quantities are added. Hope you got this. Now second, rule for multiplication and division. Again I will start from this example. Same values. The length of marker 14.3 with a uncertainty 0.1 centimeter, and the second length again same length 20.3 with uncertainty 0.1. X means 14.3, del x is 0.1. X is 14.3 and del x is plus minus del x is 0.1. Here y, here the y is 20.3 and the del y is 0.1 centimeter. Multiplication and division. First multiplying, then dividing. Multiplying. X multiplied by y. X multiplied by y. But uncertainties are added. Only not percentage uncertainties. Percentage del means uncertainty in x. Del means uncertainty. Percentage uncertainty in x plus percentage uncertainty in y. X multiplied by y, but uncertainties are added. Percentage uncertainties are added. X multiplied by y, x 14, y 20, 14 multiplied by 20. 14.3 multiplied by 20.3, you will get 290.3 centimeter square. Plus minus percentage uncertainty in x. How can you calculate percentage uncertainty? Percentage uncertainty means 0.1 divided by 14.3 multiplied by 100. 0.1 divided by 14.3. 0.1 divided by 14.3 multiplied by 100. It's a percentage uncertainty in x. Then plus percentage uncertainty in y. Similar to this, 0.1 divided by 20.3 multiplied by 100. 0.1 divided by 20.3 multiplied by 100. This is the percentage uncertainty in y. This will come as it is, plus minus as it is. After division and multiplication by using calculator, you will get 0.69%, and after simplification of this quantity division and multiplication, you will get 0.49%. Again, this will come as it is, 1 point. 40 multiplied by 20, centimeter multiplied by centimeter square. But here no units, because 0.1 is in centimeter. In centimeter, 14.3 is in centimeter. Centimeter, they will cancel out. So they have no units. 290.3 has units. Centimeter multiplied by centimeter square. But this quantity has no units. Now, after addition, you will get 1.8%. Hope you got this point. For multiplication, and now for division. For multiplication, xy is equal to z, so replace xy with z. Then plus minus percentage uncertainty in x plus percentage uncertainty in y is equal to percentage uncertainty in z. So percentage uncertainty in x plus percentage uncertainty in y is equal to del percentage del z replaced with this. Now multiplying, no dividing. Again, not dividing x and y, x divided by y, but still uncertainties are added. In multiplication, uncertainties are added. In division, x divided by y, x multiplied by y, addition. X divided by y, addition. So uncertainties are added in both multiplication and division. In addition and subtraction, uncertainties are added. The difference here is absolute uncertainties are added, but here percentage uncertainties are added. The only difference. X divided by y, x 14, y 20. X divided by y means 14 divided by 20. 14.3 divided by 20.3, you will get 0.7. Then plus minus percentage uncertainty in x. In x, 0.1 divided by 14.3 multiplied by 100. 0.1 divided by 14.3 multiplied by 100. Then plus percentage uncertainty in y. In y, 0.1 divided by 20.3 multiplied by 100. Uncertainty divided by quantity multiplied by 100. So after simplification, they are same. They both are. So after simplification, we will get 1.18%. So the formula is, whether you multiply or divide, x multiplied by y, x divided by y, whether you multiply or divide, percentage uncertainties will only be added. Percentage uncertainties will only be added. This is the formula. Hope you got it. Whether you multiply or divide, percentage uncertainties will only be added. Will only be added. Added in division, added in multiplication. Percentage uncertainties will added. And this is the rule. Percentage uncertainties are added. Here percentage uncertainties are added in multiplication, in division, percentage uncertainties are added. Now move to the rule 3. Rule for power of a quantity. Again, I'll start from this example. Here the value of x, here the value of x is 5 and the uncertainty is 0.1 centimeter. X is 5, uncertainty is 0.1, n is 3. Power rule. Same 5 as it is, plus minus as it is. First calculate the percentage uncertainty. Percentage uncertainty 0.1 divided by 5, 0.1 divided by 5 multiplied by 100. Power as it is. In next step, 5 as it is. After division and multiplication, you will get 2% in power as it is. Now, listen carefully. Here, you can't open the cube formula, a cube plus b cube, because it's uncertainty. The rule for uncertainty is multiply power with percentage uncertainty. Power is 3. This is percentage uncertainty. 3 multiply. And the quantity has power. This 3 will become here, but this power 3 will multiply with percentage uncertainty. This is the rule. Look here. Multiply percentage uncertainty by the power. Multiply. This is the percentage uncertainty. Multiply percentage uncertainty by the power. 3 multiplied by percentage uncertainty. It's a rule. Remember this. Power rule. Rule for power of a quantity. Uncertainty rule for a power of a quantity. Whenever uncertainty has a power, multiply it with the percentage uncertainty. So 5 cube is equal to 125 centimeter. 5 cube and centimeter cube. Plus minus after multiplication 3 to the 6, 6%. Now come to the formula. Oh, look here. Again. Power n, power 3, power n. Again. This power will come on x, then plus minus. This power will multiply with percentage uncertainty. Uncertainty in x, but this power will multiply with percentage uncertainty. This is the percentage uncertainty. X power n is equal to z. So this is replaced with z plus minus as it is. Percentage z n multiplied by percentage uncertainty in x. N multiplied by percentage uncertainty in x is equal to percentage uncertainty in z is equal to percentage uncertainty in z. Now, after simplification, the rule is multiply percentage uncertainty by the power. Multiply percentage uncertainty by the power. Percentage uncertainty by the power. It's a rule. Now, fourth one. Rule for average of many measurements. Average of many measurements. Many means more than one measurements. Again, I will start from this example. For many measurements, we have 3 measurements here. Many means more than one. Here we have more than one, 3 values. R1 1.5, then second value 1.51, and the third value 1.52 centimeter. So to find the uncertainty of this value, three steps are required. Number one, find the average value. Find the average value. Average value, to find the average, add all three values: 1.51 plus 1.5 plus 1.52. Add all three, divide by 3. So after addition and division, you will get the average. Average is represented by R with bar. So it's the average value, 1.51 centimeter. Average. Now second step, find deviation of each value. Deviation means difference from average value to original value. Difference from average value to original value. Look here, deviation in R1. Average value 1.51, this is the average value, minus R1. R1 is 1.5. 1.5. After simplification or subtraction, we will get 0.01. It's a deviation in R1. Now deviation in R2. Again, average value 1.51 minus R2. R2 is 1.51. After subtraction, 1.51 minus 1.51, we will get 0. Now deviation in R3. Again, average value 1.51 minus R3. R3 is 1.52. Deviation must be taken as positive. So here deviation R3 is 0.01. Now the fourth step, find the mean deviation. Mean deviation or average deviation. For average deviation, and it's known as uncertainty, add all three deviation in R1, deviation in R2, 0.01 plus 0, 0.01 plus 0, and deviation in R3, 0.01. Add all three deviation divided by 3. So we will get deviation in R, which is also known as uncertainty. It's average deviation or mean deviation. Find mean deviation, or, and it is also known as uncertainty. Mean deviation is also known as, this is the uncertainty. So the final result, R is equal to average value 1.51 plus minus uncertainty. This is uncertainty, 0.007 centimeter. So three steps. First, find the average. Here we find the average. R1 plus R2 plus R3, R1 plus R2 plus R1, R2, R3 divided by 3. Second, find deviation. Deviation, average minus R1, average minus R2. R bar is average. This is the R bar is average. Average minus, or I means 1. I means 1. Then 2, 2, then 3, 3. 2, 2, then 3, 3. Then find average deviation or mean deviation. It's average deviation or mean deviation. Hope you got it. Now the last and the fifth rule for uncertainty is for timing experiment. What does it mean, timing experiment? This simple pendulum is timing experiment. Now this is stopwatch. One, 2, 3, 4. This count the number of vibrations and note the time by using stopwatch. Find the time period. Total time, for example, for 20 vibrations. Here it's one vibration. For 20 vibration, the time is 20 vibration, number of vibration 20, and time is 35.2 seconds. You can calculate, note the time by using this stopwatch. So divide total time divided by total number of vibrations, you will get the time period. Time period is a time to complete one vibration. T is the total time for n vibration. N vibration T is the total time. After dividing, you will get the time period. No uncertainty. Uncertainty is the least count divided by total number of vibration. The least count of this stopwatch is 0.1 second. Least count is the minimum measurement or minimum time period that this stop can measure. The minimum time that this stopwatch can measure is the least count. So the least count of the stopwatch is 0.1 second. So least count divided by number of vibration, you will get the uncertainty in time period. By putting this value, you can check this.